Introduction to calculus. Calculus is mainly dealing with quantities that are continually changing, which vary in a non-linear form. It is mostly used in the science and engineering field because the study of some quantities like current in a circuit, velocity, and acceleration does not behave in a simple linear form. This is a graphical representation of integration and differentiation, which is differential calculus and integral calculus. The green line, which is the slope, is representing differential calculus since it means change in y over change in x, which is dy dx. Also, the yellow shaded portion is an area under the function of y is equal to f of x. And to find the area bounding between A and B, we use the concept of integral calculus, which is area is equal to integral of f of x dx from A to B. Now let's move on to function. The calculus has the notation that shows how the value of one quantity depends on the value of another quantity. For instance, the acceleration a of a body in motion depends on the velocity v and the time taken during the motion. So the relationship between the three quantities were expressed by the formula a is equal to delta v over t. Delta v, it means v minus u, which is change in velocity. So when the value of one quantity depends on the other quantities, we shall say that the first quantity is a function of the other quantities. Therefore, acceleration is a function of velocity and time taken. Now, the statement y is a function of x is expressed mathematically as y is equal to f of x. The f is used to indicate dependence of quantity in the bracket, that is x. Y is equal to f of x shows that as the value of x varies, the value of y varies in a way determined by the particular function. This means the value of y depends on the value of x. Example: if f of x is equal to 2x cubed plus 3x minus 5, let's evaluate the following problems, in which number 1 is f of minus 1, number 2 is f of 0, number 3 is f of 1, and number 4 is f of 2. In this aspect, we will need to substitute for value of x. So, number 1, f of minus 1 is equal to 2 instead of x is minus 1 raised to power 3 plus 3 into minus 1 minus 5. Now, minus 1 raised to power 3 is minus 1. So, minus 1 times 2 is equal to minus 2. So, this one is also minus 3 minus 5 is equal to, adding everything together, we have minus 10. So, f of minus 1 is equal to minus 10. It is the value of y. Moving to number 2, we have f of 0. So, f of 0 is equal to 2 into 0 raised to power 3 plus 3 into 0 minus 5. So 0 times 2 is equal to 0, and this one also 0. It remains minus 5. So the value of this is minus 5. So f of 0 is equal to minus 5, which is the value of y when x is equal to 0. Now for number 3 is f of 1, which is equal to 2 into 1 raised to power 3 plus 3 into 1 minus 5. So 1 raised to power 3 is 1, 1 times 2 is 2, so 3 times 1 is also 3 minus 5. So adding it together we have 0. So f of 1 is equal to 0. It is a new value of y. And for the last one, we have f of 2. So f of 2 is equal to 2 into 2 raised to power 3 plus 3 into 2 minus 5. 2 raised to power 3 is 8. 8 times 2 is 16 plus 3 times 2 is 6 minus 5. So adding it together we have 17. So this is another value of y when x is equal to 2. Because that y is equal to f of x, so it means f of minus 1 is equal to minus 10, means y is equal to minus 10 when x is equal to minus 1. And also f of 0 is equal to minus 5, which means y is equal to minus 5 when x is equal to 0. As well, f of 1 is equal to 0, means y is equal to 0 when x is equal to 1. And when x is equal to 2, y is equal to 17, which is f of 2. Now there is cases of a function. Note, y is defined only if any value of x is defined. For instance, y is equal to f of x is equal to 3x minus 5. The second one is y is equal to f of x, which is equal to 1 over x minus 5. These are two cases. Now, case 1 is if y is equal to f of x, which is equal to 3x minus 5. In this case, y is defined for all value of x, since to any value of x, we will obtain a value of y. For the second cases, you can see that x is in the denominator and we have to consider the denominator not to be equal to 0. So in case 2, if y is equal to f of x is equal to 1 over x minus 5, for this, y is defined for every value of x except when x is equal to 5. Since if we try to evaluate y when x is equal to 5, we will obtain 1 over 0, which is undefined and it is meaningless. So there won't be any value for y when x is equal to 5. Now in considering implicit and explicit functions, the functions just considered y is equal to f of x is equal to 3x minus 5, and also y is equal to f of x, which is equal to 1 over x minus 5 that we have just considered. They are both cases where y is an explicit function of x. In other case, it may also be that the relationship between the quantities y and x is expressed in the following equations. Number 1 is y plus 3x is equal to 5. Number 2, 3y square plus 5x is equal to 2. 3, 2y square plus 4x square is equal to 10. In this situation, we will say that y is an implicit function of x, though y can be expressed as an explicit function of x. Now, if we study implicit and explicit function of x closely, we will notice that implicit equation, there is y and x mixing together in the equation, but in explicit function of x, y is a subject of formula of the equation. So this is the clue to differentiate between implicit and explicit function of x. Now let's express the following equations as an explicit function where y will be an explicit function of x, which means y will be the subject. Number 1, y plus 3x is equal to 5. By subtracting 3x from both sides, we have y is equal to 5 minus 3x. This shows that y has become an explicit function of x. Now, number 2, we have 3y square plus 5x is equal to 2. By subtracting 5x on both sides, we have 3y square is equal to 2 minus 5x. Now, by dividing both sides by 3, we have y square is equal to 2 minus 5x all over 3. So, the next thing is to square both sides. We have y is equal to square root of 2 minus 5x over 3. This has also become an explicit function of x. Now let's move on to graphical representation of a function. The below graph shows the graph of the function y is equal to x squared, and it is a smooth continuous curve over the range of value of x for which the function is defined. So note that this is an example of continuous function of x. Another graph representation of a function is the graph of the function y is equal to 1 over x, so which is an example of discontinuous function of x. So this graph shows that there is a break in the curve when x is equal to 0, which means the function is not defined when x is equal to 0. So that is why it is discontinuous function of x. Now let's move on to the rate of change of a function. In this aspect, in considering the above graphs, if y is equal to f of x, as x changes, y will also change. Therefore, the average rate of change of the function will be represented as delta y over delta x is equal to bc over ac, which is also equal to b prime c prime over a prime c prime. But note that when the y and the x approach 0, the rate of change of a function will become dy dx. Thank you. We continue in the next video. Please don't forget to subscribe, like, and turn on notification for new video. Thank you for watching. Watch out for the next video. Check in the playlist in the below description. Thank you.